This video is about the properties of water because we're looking at analyzing soda or other drinks, and one of the main ingredients is water. The question is, what are the properties of water? What makes water so special? To answer that question, we need to understand some of the characteristics of water. One is that water is inorganic. That means it's not a complex molecule. It does not contain carbon. Organic molecules typically contain carbon, and they are unique to living things, like sugar would be an organic molecule. But inorganic molecules do not contain carbon, and water is a great example. Here's the chemical formula of water and the structural formula of water. The first thing we want to notice is that there's one oxygen atom. There are also two hydrogen atoms. They are sharing electrons with that oxygen atom in a covalent bond. Water molecules often form weak hydrogen bonds, and those characteristics determine all kinds of properties about water. A hydrogen bond forms because water is polar. Sometimes it's called a polar covalent molecule. Polar because the side that has the oxygen is negative, the side with the hydrogens are positive. Those hydrogen bonds are just a weak bond between the attraction of the negative of one side and the positive of the other. This hydrogen bond creates all kinds of properties of water, and the polarity of water gives us all kinds of properties of water. So let's take a look at some of these properties, because we normally call water a polar covalent molecule. Polar because one end is positive, the other is negative. Covalent because they share those electrons. All right, so polar covalent molecule. So what are these properties of water? Well, we'll look at several. Cohesion, which just means the water molecules stick together. Adhesion, which they stick to other things. That water is a universal solvent. It can dissolve things. That it has surface tension, so things can rest on the surface of the water, not float, but rest on the surface of the water. It expands when it's frozen, which is unique because everything else gets smaller when it freezes. It has a high specific heat, which means it takes a long time to heat up and a long time to cool down. And it has this phenomenon called capillary action. Water moves through very tight spaces, even against the force of gravity. We can remember these properties of water with this little acronym, causes CA. Let's start with cohesion. It just means that water molecules stick together. They're sticking together because of those hydrogen bonds. So those hydrogen bonds form this attraction between the molecules. It causes drops or drips to form. It causes water to sort of mound up whenever it's on a surface. Adhesion just means it sticks to surfaces. So here you can see the drips or drops. Those are because of cohesion, but sticking to the grass itself, that's adhesion. It sticks to other things. Water is a universal solvent. That because it's polar, it can break other molecules and bonds apart. So it can dissolve things that are hydrophilic. It means water loving. It can't dissolve nonpolar things like oils and lipids. Surface tension, because of those hydrogen bonds, things can rest on the surface, like this water strider can rest on the surface. It doesn't float, it just rests on the surface of the water. Unlike most other things in the world, water expands when it's frozen because those hydrogen bonds are repelling from each other. So as they get closer together, they'll expand whenever it reaches that freezing point. So water is less dense as a solid, which means ice floats. That's very significant to things like fish, where the ice is formed on a layer across the top, and the fish in aquatic life can survive underneath. Water generally has a high specific heat. That means it gets cold, but it takes a long time to get cold. It warms up, but it takes a long time to heat up. So that areas that are near large bodies of water don't have dramatic changes in temperature, like areas that are like the Midwest, for example. Because your body is made mostly of water, you don't heat up quickly or cool down quickly. Your body temperature stays about the same. And then this phenomenon of capillary action is really important to plants, where we're using the property of cohesion, water sticks together, and adhesion, water sticks to other things, so that these drops of water can move through very, very tight spaces, even against the force of gravity. So this is how plants can get water from their roots all the way up to the treetops. This is also the same principle of paper towels. The small spaces in paper towels absorb water, it just brings it in through these little tiny spaces, capillary action. So I hope now that you've seen some of those properties of water, you get a little better understanding of what water is like.